Hello students, this is problem set 2. Now this chapter is kinematics and you have to make sure that you understand the concepts of velocity and acceleration, and you know what displacement means, and also you have gone over the kinematic equations. Now we did all this during the lecture, but we have to know the kinematic equations in order to solve the questions. So let's jump into question 1. This question is to deal with a graph. So whenever you get given a graph, the first thing that you have to look at is what are on the axis. So if you look at this x-axis, you see time. Now usually the unit would be given, it would be seconds. So time is on the x-axis. It's an independent variable and therefore it's always on the x. And on the y-axis we have velocity. So you know that both time and velocity start at 0 here, which means if you're going to the right, time is increasing, and time can only be positive. That's why you don't have the negative x-axis. You don't have that. Time can never be negative. But when you look at the velocity axis, you see that velocity going up is positive and going down is negative. Now velocity is a vector, and so it can be both positive and negative. On the other hand, as I mentioned before, time is a scalar, therefore it can only be positive. Now, before we go to the questions, I've given you three examples. You can see that on the first one here, this one, you can see that the velocity is actually increasing from 0. Look at that. It's going up from 0. So the velocity is going up, but the rate at which the velocity is increasing is getting less. That means if this line had been straight like that, that would have been a constant change in velocity. See, that means the velocity was going up consistently. But now, although the velocity is increasing, it's not going up at the same rate. The rate of increase is actually slowing down. So the rate of increase of velocity is called acceleration. That's why in this graph, yes, the object has an acceleration, but the acceleration is decreasing. A lot of times this is confusing for students because you have to know that what you're looking at is velocity. That means at this point, there is a certain velocity at that time, and at this point, the velocity is bigger, right? The velocity is bigger than at the first point. But the rate at which the velocity is increasing is slowing down. I hope that makes sense. On the other hand, if you look at the second example, you see that again the velocity starts from 0 and the velocity is increasing. Yeah. But now the rate at which it is increasing is going up. So that means the acceleration is going up. So the acceleration is increasing. So you have to know the difference between velocity and acceleration. Velocity is what is shown on the graph, but the slope is what is showing you the acceleration. S-L-O-P-E, slope. Now look at the third example. I just wanted to show that velocity can be both positive and negative. So here you see that the velocity has some positive value, and then the velocity is decreasing, right? What's the velocity here? The velocity at this point is zero, of course, because that's zero. And then it continues to become negative. So what does that mean? So from this point to this point, the velocity is positive, but from the second point to the third, it's negative. What does that mean? That means the object is moving in the opposite direction. So maybe in this half, it is moving to the east, and in this half, it's moving to the west. Now, if something moving to the east has to move to the west and in the same line, doesn't it have to stop there and then go back? You see what I'm doing? So it has to go that way, and then if it's coming back, it had to stop here. That's why the velocity is zero here. Hope that makes sense. So now let's go to the questions. Which motion has the largest acceleration? So when you're asked to find the largest acceleration, you're looking for the biggest slope. Which one is more inclined? Not giving you the answer, but you got to look at these graphs 4, 5, and 6 and find out which one is sloping the most. And so that is what you give us the reason. You find out which graph, give the number of the graph, and say that it has the largest acceleration because it has the biggest slope. Now it says which one has the smallest initial velocity. Is it number 4? Some students, they look at this and say, hey, that's a negative velocity. Sure, it is. But remember, negative in a velocity only shows direction. So this could be -1. So it has a velocity of 1 in the opposite direction. So is that the smallest velocity? Or is it 0? You got to find out. You got to. So the question is it 4 or is it 6? Which has a constant acceleration? Of course, that means we're looking for straight lines. There are 3 straight lines. If it's a straight line, then the object has a constant acceleration. So I think I've given you the answer to that. All 3 are straight lines, but since the slope of this is 0, if you say that you want to include number 5, you'll have to say, yes, it's a constant acceleration, but the acceleration is what? 0 consistently. Okay, I hope you got the answer. Is it 2 of them or is it 3 of them? So look for the lines. If it's a straight line, the slopes are constant. Then the last one, which has an acceleration of 0? Why? I've given you the answer. I've told you flat line. Horizontal line means the slope is 0. So which one is the horizontal line? Which is the flat line? That is the answer. Okay, so that's number 1. In question number 2, an elderly woman took 8.5 seconds to walk 5 meters during her physical therapy session. So you're given the time and you're given the distance. See that? Time and distance. What's the question? What was her average speed? Now remember that speed and velocity can be used interchangeably. So even if it says speed, it's actually velocity. And the formula for velocity is distance divided by time. So I've given you the distance. You can call it d or you can call it delta x. Doesn't matter. So you should get the answer because you're dividing meter by second. You're going to get the answer in meter per second. Now you have to change her speed into kilometer per hour. So you don't write HR. That's a mistake. It's actually kilometer per h. Now, you know the chain link conversion that we did in chapter 1, so that should be easy. You just need to know that kilo means 1,000. So 1 kilometer is 1,000 meters, and 1 hour is 3,600 seconds. Okay. C. Is this patient able to safely cross the street? Now that's just a comparison. After you get the average speed, look at the number that you got and see where you can situate that and answer accordingly. Okay? Now let's go to number 3. So in number 3, we come to the kinematic equations. So what you have to do is you have to read the question very clearly. Very carefully, Like, get everything clearly in your head. A car is 100 meters from an intersection. So you're even given a picture here. The car is here. There's 100 meters to go before the car reaches the intersection. And right now it's moving at 20 meters per second. When the driver observes the traffic light ahead turn yellow. So the yellow light will turn red in 4 seconds. So 1, 2, 3, 4, and it turns into red. So now the driver has 4 seconds, probably 4 seconds, to decide whether they should step on the accelerator or step on the brakes. And by default, if you see the yellow, you're supposed to step on the brakes. I'm sure you know that. So that's what this driver does. But between seeing the light turn yellow and hitting the brake, there's going to be a small amount of time that's called the reaction time. And the reaction time is given here in part A. Will the car be able to stop if the driver's reaction time is 0.25 seconds and the brakes can produce a deceleration of 5.0 meter per second squared? So now, what are the quantities given? You know the car was moving at 20 meter per second. That is the initial velocity. So the velocity at the beginning. So that's what is given here, the initial velocity. And then the car is supposed to stop, so the final velocity is 0. And then the acceleration, in fact, the deceleration is 5.0. Now, when you say deceleration, that means the acceleration is negative. Don't be confused. Deceleration is another word used to show that it's slowing down, which means the acceleration is negative. So whenever you see the word deceleration, you have to put a negative for the acceleration. Okay, so that's what I've done. So you got one term here, 2, you're given this, and you're asked to find what? Will the car be able to stop before it passes the signal? Understood. So what are you looking for? You're looking for distance, which is delta x. Okay? And the kinematic equation that connects these 4 equations is this one. And a lot of times I've heard this question from students. You given us so many equations, how do I know which one to use? That's why you had to list all of them down. See, you listed them down, and then you look at the equation that has those in the list. So you got 4 quantities here, 1, 2, 3, and 4. And this is the equation that has, does it have all of those terms? Well, not yet, because I did not tell you about time, but see, the time is given. It's 4.0 seconds minus the reaction time. Now, why should we subtract the reaction time? Because the car now only has 3.75 seconds to stop. 4 minus 0.25. So the time is also given. So when you consider that, then you can use this equation. And use this equation because you have all the terms on the right side. Put it in, calculate the displacement or the distance, and check if it's less than 100. If it is less than 100, you're going to say, yes, the car will be able to stop. If it's more than 100, you're going to say, no, it won't stop. Now, there's another way to do this question. You don't have to do it, but I'm telling you that from these 4, you can actually also use this equation to work the same problem out. Again, you don't have to do it two ways. Either use this or use this. Both cases, you're looking for distance, and if it comes out to be less than 100, it's going to stop. And from both the equations, you are supposed to get exactly the same answer. So check that out. Now, coming to the B part, this is a driver who decides to try to make the light, some step on the gas. And so that means you're trying to accelerate, and taking the reaction time of 0.25 seconds into account, what acceleration must the car be able to produce to make the light? So the question is, how hard should he hit the gas to be able to make it before it turns red? So what do we have now? What are the quantities we have? We have the distance to go as 100 meter. Also, we have the initial velocity of the car, 20 meter per second. We have the time, and we're looking for the acceleration. Once again, you see that these 4 quantities are available in this equation. See that? So plug those in. Remember, you're going to put 100 here, and then likewise the other terms, but this is unknown. So keep this term separate, do the algebra properly, find the acceleration. Okay. That is question number 3. All right, question number 4. Once again, we have a velocity time graph. Velocity on the y, time on the x. Look at the graph. You see that as the object starts with 0 velocity, the velocity is increasing to 20 meter per second in 4 seconds. So I had to draw these lines straight down to figure out what that time is. So that's 4 seconds. It's reached 20. And then from the 4th second to the 12th second, it stays at that same velocity of 20. It's not accelerating, it's not decelerating. But then from the 12th second to the 20, how much is that? 22? Yeah, 22nd second, so 22 seconds, it is slowing down, it's decelerating because the velocity becomes 0 here. So that's the graph. So what are the questions? Determine the acceleration from 0 to 5. So you only look at 0 to 5. Look at that. You look at this part of the graph. You got to find the acceleration. Now, it's only accelerating up to the 4th second, because after that, for 1 second, it's a constant velocity. See that? So although it says the time is 5 seconds, the trick is to consider the time to be only 4. Why? Because it's not accelerating from 4 to 5, okay? So here are the given terms. You have the initial velocity, 0. The final is 20. You have the time as 4.0 seconds. I told you why. And you have to find the acceleration. Here is the kinematic equation. Plug it into that equation. Be careful with your algebra and you get the answer. B part. Find the deceleration from 12 to 22. So 12 to 22. What was the initial velocity at 12? It was still 20. That's why I put 20 here. What's the final velocity here? The time is 22 seconds, but the velocity is 0. See that? Velocity is 0. Okay. And the time is 10 seconds. That's the time between 22 and 12. 22 minus 12 is 10. Once again, use the same equation and find the deceleration. So you're going to get a negative number if you put this and work it out correctly. In the C part, you have to find the total distance. Now, if ever you're asked to find the distance from a velocity time graph, you have to find its area. So in this case, you have to find the area of region A, this region B, and find the area of C separately, and then add them up. To find the area of this part A, you see it looks like a triangle. It is a triangle, of course. So you know that the area of a triangle is half base times height. Yeah, the base is 4, the height is 20. Oh, I told you. And then do that. Now in the B part, so it's a rectangle. So the area is just base times height. Remember, the base is from 4 to 12. The height is again 20. And then C part is again a triangle. This is the base. See how much that is. And then find the areas and add them up, and you will get the answer. All right, that brings us to the last question. Okay, a bicyclist is initially moving at 10 meters per second, so that's the initial velocity, and accelerates at a rate of 1.5 meter per second squared, so that's the acceleration for 3.0 seconds. So you got three quantities there. Moving initially, acceleration, time. See that? What do you have to find in part A? Final speed, which is here. And here's a kinematic equation relating those four quantities. See the four quantities here? That equation relates the four quantities. Put that in there, solve it. B. How far has he traveled in those 3 seconds? So when you say how far, you're looking for distance, delta x. So I think this is at least the third time that we're using this equation. All of those quantities you know are given. Plug it in, do the math. C part. If the brakes apply a deceleration of 1.0 meter per second squared, how long would it take them to stop? Now again, you have the word deceleration. What do you remember? If it says deceleration, then you know you have to put it as negative. That's what I've done here. A is negative 1.0. Initial velocity is 10 because it's given. And it says how long would it take for them to stop? If anything stops, what is the final speed? 0. So, and then what are you looking for? How long means time. Once again, it's this equation that's going to be applied for you to find. And then it says, how far did they travel while slowing to a stop? Because you know that as soon as you apply brakes, it's not going to stop. It's going to continue to move a certain distance and then stops. So now you have to find out that distance. I don't think I have to give you the equation. You should be able to figure out by now. But I just gave you this. This is what you're looking for. How far means distance. But then you got to look at what else is given, apply the equation, and you will be able to finish it. So that is the end of problem set 2. Really, I know I'm going a little fast, but you can always pause, look at it, think about it, and you really have to use your critical thinking. Because for many of you, if not most of you, this is the first time that you're doing reading, math, and thinking all three together. So it's going to be a little hard at the beginning. That's why I'm giving you clues, but don't give up. Just try to do it. And with all the practice and the homework after this, you will do good on the exams. Believe me. But you have to persist. You have to be like, I'm going to do this. And look at it. It's not going to be as easy as memorizing stuff, like in so many other places. That's all I want to say. Here, you have everything coming together. You have to read, understand, you have to use math, and you have to do the thinking. All three coming together, that's what makes this subject a little hard,